Dear calculus students, today I have a very nice question for you. The question reads, assume f and g are differentiable functions with h of x equal to f of g of x. Suppose the equation of the line tangent to the graph of g at the point where x is equal to 1 and y equal to 8 is y equal to 4x plus 4. And the equation of the line tangent to the graph of f at the point where x is equal to 8 and y equal to 7 is y equal to 3x minus 17. We are asked to determine an equation of the line tangent to the graph of h at the point on the graph where x is equal to 1. Alright, let's get started. I would like to start from the function h. Let's assume we have the graph of h like this. Something like this. Just an example. This is a graph of h of x. You know, a tangent is a line that touches the curve at exactly one point. But in this case, at exactly where x is equal to 1. So suppose we have x equal to 1 here. So we may have a tangent line touching this curve at this point. So we asked to find the equation of this tangent line. So the equation of this line can be written as y minus y1 equals mx minus x1, right? I should know that if x is equal to 1 here, we may find a corresponding value of y, which is y1. So if you come directly here, you can pick a point here by substituting 1 into the function. Therefore, at this point, we have h of 1. And h of 1 is nothing but y1, right? So we can rewrite that equation as y minus h of 1 equals m, which is the slope, multiplied by x minus x1, which is 1. So minus 1. So the only things we need to find are h1 and m. Let me start with h1. To find h1, remember the function given to us is what? H of x equal to f of g of x. Let me write it here. We have h of x equals f of g of x. So h of 1 is nothing but what? F of g of 1, because x equal to 1. So we need to find what is g of 1. Let's go back to the function g. This is the function g. We learned that when x is equal to 1, y is equal to 8. And hence, g of 1 is equal to 8. Therefore, h of 1 is nothing but f of, we know that this is 8. So we have f of 8. And again, we need to find what is this f of 8. Let's go back to the function f. This is the function f. At exactly where x is equal to 8, y will be equal to 7. Therefore, f of 8 is equal to 7. So we have h of 1 to be equal to 7. So now we have h of 1, which we can now plug back into this equation. Let me write it here. We have y minus 7 equals m x minus 1. The only thing we need to find again is m. And how can we find m? M is nothing but the slope of that curve at exactly where x is equal to 1. And which function is that? H. Alright, remember that h is given as what? F of g of x. So to find m, which is the slope of the curve at exactly where x equal to 1, we need to differentiate the function h and substitute x equal to 1. So what is h prime of x, which is the h over the x, is equal to, you see this is a composite function, therefore we are going to apply chain rule. First of all, we differentiate the external function, that is f. We differentiate it, keeping this as constant. Then we multiply by the derivative of the inner function, which is g prime of x. Now the slope m, you know, it is the same thing as what? H prime of 1, which is equal to f prime of g of 1 multiplied by g prime of 1. So let us find g of 1. I think we have it somewhere else. You see that? G of 1, it was 8. So we can plug in 8 there. So we have m to be equal to f prime of what? 8 multiplied by g prime of 1. So what is f prime of 8? Let's go back to the function f. So this is our function f. Remember, if you differentiate f, you plug in 8 into the function, the derivative of f, you're going to obtain 3 exactly. Because 3 here is m, which is the slope of that tangent line. And to get the slope of that tangent line, you need to differentiate that function, substitute the value of x, and it will give us 3. Therefore, f prime of 8 must be equal to 3. So we have m to be equal to 3 multiplied by g prime of 1. We need to differentiate g and plug in 1. Where is g? This is our g. If you differentiate it and plug in 1, you're going to obtain 4. So we're going to substitute 4 here, multiplied by 4. And therefore, m is equal to 12. Now let us plug in m equal to 12 into that function. This is that. So we have y minus 7. Y minus 7 equal to m, which is 12, multiplied by x minus 1. We may decide to take this one to the other side. We have y equals, we can even expand this. We have 12 times x is 12x minus 1 times 12. Then as negative 7 crosses over, it becomes positive 7. And negative 12 plus 7 is negative 5. Finally, y equal to 12x minus 5. And hence, this is what? The equation of the line tangent to the graph of h. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.